Good afternoon, guys. We are the AnyLog remote GUI team. I'm Poria. We have Andrew, Brian, Parth, and Justin.
All right, let's talk about what AnyLog does. So if you have edge data, so that can be like sensor data from robots, camera data, any type of real-time data or metrics, you'd want to be able to manage or query that, right? And let's say like a distributed system. The traditional way to do this would be through like a cloud service. So you'd have your edge servers route it to a cloud service for it to be processed, and then you would manage and query from the cloud directly. But this can be costly, and there can be a lot of processing and routing times to do that. So what AnyLog does is provide you AnyLog nodes, so you can manage your own network of edge servers. And it's decentralized, so that means the data doesn't live on just any one node. But the remarkable thing is that if you interact with one of these nodes, it behaves much like you're working with a centralized service. And because your querying is close to these edge servers and your edge data, it makes processing time a lot faster and can be a lot more cost effective. And the nodes do this by communicating with AnyLog's very own AnyLog API, and let's go talk about how you can interact with one of these nodes.
So the previous way of interacting with an AnyLog node was via a command line interface. You would type a command into your terminal, a text-based command, and you would get text or binary back. Now this is a very functional way of interacting, but for some users it's not very intuitive. That's where the remote GUI comes in. What it does is it wraps around the pre-existing CLI and provides a graphical alternative interface to the CLI. It's a web application that can run on pretty much any system that supports Docker, and it provides a whole bunch of graphical features that simply were not possible with the command line interface, such as we have listed here a few examples: video streaming, executing SQL queries, monitoring node resources, etc.
So the problem with the previous version of the remote GUI is that it was implemented as a monolithic web application. And because there's no separation of core functionality and extendable features, this leads to a large Docker image size. And clients may not need all features at once, and the lack of modularity leads to maintenance and development of plugins to be more complicated.
All right, and throughout this project, we have 5 major goals we want to achieve. One being the plugin marketplace, which allows for dynamic plugin loading, and 4 of our own plugins, being the MCP client chatbot, adding monitoring to Grafana, an SSH client, and also a file uploader.
So the plugin marketplace is how we implemented adding external features and enabling them on the fly. So we have our 4 plugins right here, and they're pulled from a registry. And a registry is essentially just a file that holds plugins like metadata, like name, identifier, and download link. And so a user can add as many registries as they want. And before they choose to install, you can use, you can view a plugin's README that's written by the author, and you can also visit the repository. So once you choose to install a plugin, it will download the plugin onto the node, it will extract it, it will install its dependencies, and then it will serve the plugin. So right here is our SSH plugin, and to view advanced plugin stats, you can see its CPU usage, memory usage, and logs all in real time. And plugins can be disabled and enabled on the fly at runtime without having to restart the GUI. So the next plugin is the MCP client. MCP stands for Model Context Protocol, which is a way to enable external interaction between an LLM and a third-party service. And so this chatbot. So I gave my chatbot a query to get the last 20 entries for 3 key values. I also told it to give me a chart and the data. So it got the data from the AnyLog's MCP servers, and then it's plotting a chart right now in real time, which should show the trend of the data and then show some insights as well. And once the table's done generating, you can see the data neatly organized. For each visualization, you're also able to download the data in JSON or any other format.
So we used Grafana to basically have a whole overview of our system metrics of the said nodes. It was basically an easier way to visualize it, as the only way to look at it right now was through a really long list of tables and just numbers that kind of didn't make sense at the time. This allows you to see the CPU percentage and used of from that specific node. It was basically just the easier way to view the real-time system health and performance metrics.
Now we're going to look into the remote CLI, which is basically the SSH client. So basically what it allows you to do is to choose from a list of nodes to remotely open AnyLog CLIs or terminals. And the purpose of it is to quickly open remote consoles connections from one place. You don't have to memorize IP addresses, none of the above. And it's a quick demo. So initially, we created a vault that is going to actually encrypt the SSH passwords and the SSH keys. From there, you can just SSH into your server as you normally would, providing a host, a port, and a password. You can also Docker exec and Docker attach into the node itself, which is basically going to allow you to type in any log commands such as help or etc. If there's something wrong with a node, this is the best way to actually go into it and debug it. Just giving you access to the CLI again. And also going into the vault and removing a password no longer pre-populates the field in case someone's taking over your computer that day.
Okay, and then our last plugin is a drag and drop file uploader. So originally it would be very difficult to just upload files quickly with the CLI, so this makes it a lot easier. So first thing you do is you search for a folder in the target directory, and you can search for it. If it doesn't exist, you can create one, the default being the upload directory. Then you can drag and drop, for example, 2 small files, which it should be able to do very quickly and tell you exactly where it's stored. Now, let's say you upload a big file that's bigger than 10 megabytes, it'll give you a warning, which you can cancel or proceed. And if you try to upload the same files again, it's going to open up this view where you have to handle the duplicates. So you can choose to override what already exists in target directory. Or if you want to keep both files, then you can do that too, and it'll append a number to the file that you're trying to upload in the target directory.
So here's a simple overview of the architecture of the remote GUI. In the top right, you can see a series of AnyLog nodes all interconnected with each other, and they're all being fed various types of edge data. This could be pretty much anything you imagine. A user is able to send queries to one of these AnyLog nodes and get responses back. We can see a magnification in the bottom left of one of the nodes. Each node serves a remote GUI instance, where each instance has a front end, which handles the various UI elements, and a back end, which manages all the plugins and handles all API calls. We can also see that each plugin has its own corresponding front end and back end specifically for that plugin.
So one of the challenges we had while working on this was its pre-existing monolithic design of the entire architecture. Having to get used to it and just having to read through such an extensive amount of documentation made it really hard. So going through and applying our own functionalities and features helped us really get used to this front-end and back-end components. And finding ways to extend common AnyLog CLI approaches through the intuitive GUI plugins with its automation with the AnyLog API commands, and just executing by building REST APIs.
And our results, as you guys saw, we had 5 goals and we achieved all 5. Again, one being the plugin marketplace, and what it actually does is allows for initially lightweight remote GUI app, the Docker image can be way smaller. Allows for dynamic loading of plugins, and especially it allows for native support for plugins from external contributors. So it's an open source project, so anyone can create a plugin, clients can create plugins themselves and be able to contribute to the marketplace. And for the plugins being the SSH client, the file uploader, monitoring Grafana, and the MCP client are 4 pre-existing plugins. And our takeaways of this project being, again, this was open source, so getting a chance to contribute to an open source project was pretty cool, and none of us ever done it. We also, all of us wrote developer-facing documentation, whether that was for anyone trying to add a new plugin or just understand pre-existing plugins.
And we would just like to thank our sponsors, Roy, who got his PhD recently, and Pranav, and our instructor, Dr. Julik, and our TA, Diego. And thank you. Any questions?
Were any of the plugins useful in developing like the rest of the project?
Could you repeat that?
Did you use any of the plugins to like develop the rest of the project, like the file uploader to help you or something?
So, not necessarily. These are all plugins, so they're completely individual from each other. So if you're asking, do we use a file uploader to actually upload files for the AnyLog? Yes, but for example, like the S26 client and the chatbot are already in use for some of the clients. But yeah, we mainly work in the remote GUI and the front and back end side of things, not necessarily with AnyLog nodes themselves. That answered it.
What LLM was used for the chatbot?
It was like Quen 3, 30 billion, and I was running it locally.
Does this work for any AnyLog version?
Yeah. So this just it lives within a node. So yes. Thank you guys.
All right, 2 more to go. Next is the multiple managers. And then the Crowd Labs will wrap it up.